Welcome to The Explainer. Look, today we're not just talking about code. We're going to build a fortress, a digital fortress. We're diving right into REST API security, and I'm going to show you, step by step, how to build the essential layers you need to guard your most valuable data.
Seriously, think about it. An unsecured API is basically a castle with the drawbridge down and a giant welcome sign for attackers. So in this explainer, we're going to raise that bridge, we're going to fortify the walls, and we're going to lock down that treasure vault. All right, let's start building our defenses, layer by layer.
All right, first things first. Our initial line of defense, it's not actually the castle gate itself. Nope, it's the road leading up to it. We have to protect the messengers, the data packets, that are zipping back and forth between the client and our server. Because, let's be real, if anyone can just read those messages, then all our other defenses are pretty much useless.
And this is exactly where HTTPS, powered by something called Transport Layer Security, or TLS, comes in. The best way to picture it is like a private armored tunnel. Anything sent through that tunnel is completely scrambled, totally unreadable to anyone trying to spy on it. So here's the absolute bottom line. You must, always, use HTTPS to encrypt all your data in transit. It's the non-negotiable foundation of API security.
Okay, great. So our data is traveling safely through that secure tunnel. But what happens when a messenger actually gets to the gate? How do we know they're supposed to be there? We need a gatekeeper to check their ID, right? We have to verify who is asking for entry, and that whole process is called authentication.
A fantastic tool for this is the JSON Web Token, or JWT. Just think of it like a secure, tamper-proof digital passport. Now, the magic word here is stateless, and that's a huge deal. It means our server doesn't have to keep a big list of every single passport it's ever issued. It can just look at the passport, verify it on the spot, and that's it. This makes the whole system incredibly fast and much easier to scale.
And if you ever look at a JWT, you'll see it as three parts, all separated by dots. First, you've got the header, which just says what kind of token it is and the encryption algorithm being used. Second is the payload. This is the good stuff, the actual claims or data about the user, like their ID and permissions. And finally, and this is the critical part, you have the signature. It's a cryptographic seal that proves the passport is authentic and hasn't been messed with.
Now, this is where you can really see why JWTs are so popular. Let's compare them to the old school way, server-side sessions. With sessions, the server has to keep track of every single active user. As you can imagine, that just doesn't scale well. But with JWTs, the token is stored on the client side. Our server doesn't need to remember anything, which makes it incredibly efficient and just perfect for modern large-scale applications.
Okay, so someone shows up at the gate with a valid ID card. We know who they are. But does that mean they get to roam free and access every single room in the castle? Of course not. We need to grant specific, limited permissions for specific tasks. And that next step, well, that's authorization.
And that's exactly where OAuth 2.0 comes in. Now, let's be super clear. OAuth is an authorization framework. It's not about proving who you are. That was JWT's job. It's about proving what you're allowed to do. It's the system that allows an app to access resources on your behalf without ever needing your password. It's all about delegated access.
So let's make this distinction crystal clear. JWT is the ID card. It proves who you are. OAuth 2.0 is like the valet service at a restaurant. You give the valet a key that only works for your car. You don't give them the master key to your house. In the digital world, an application uses the OAuth framework to request limited access, and the key it gets back is often a JWT. They are two different things that work beautifully together.
So how does this valet exchange actually work? Well, this slide shows the most common and secure method, the authorization code flow. It's like a careful dance. The user tells an app they want to log in. The app sends them to the real authorization server, like Google or Facebook. The user logs in there, grants permission, and the server sends back a temporary code. The app then secretly exchanges that code for the real access token. The crucial part is that the user's password is never exposed to the application.
Okay, our castle is secure on the inside, but, it exists in a bigger world. It needs to communicate with other friendly castles, or in web terms, other domains. So, we need some rules of diplomacy to control who's even allowed to send messengers to us in the first place. By default, web browsers are super strict. They have this thing called the same origin policy, which basically prevents a script on one website from making a request to another one. CORS, which stands for Cross-Origin Resource Sharing, is the mechanism that lets our server relax those rules. It's just a set of headers our API sends to the browser that says, hey, it's okay, that other domain is a trusted ally.
You can accept their requests. Now, for simple things, like a basic GET request, CORS is pretty straightforward. But for anything more complex, like a request that could modify data, the browser performs an extra safety check. It sends what's called a pre-flight request. It's basically the browser calling ahead and asking our server, hey, am I allowed to send this kind of message from this origin? Our server then responds with the rules of engagement, and only then will the browser send the actual, real request.
So, we've dug our moat, we've built the gatehouse, issued the keys, and we've established our diplomatic relations. Now, let's bring it all together and take a look at our fortified API.
The biggest takeaway here is this. Security is all about layers. We have our HTTPS moat for encryption, our JWT gatekeeper for authentication, our OAuth system for fine-grained authorization, and CORS to manage our foreign policy. But the defenses don't stop there. A truly secure castle also needs things like input validation to inspect every delivery and rate limiting to prevent the gates from being overwhelmed. Building a secure API isn't a project you just finish. It's an ongoing commitment. We've laid out the blueprint for your digital fortress today, but the landscape of threats is always changing. The journey of a security-conscious developer is one of constant learning and adaptation. Your defenses must always evolve.